Hello everyone, I will complete solving problems of chapter 5. I will move to some sort of problems that contain systems of blocks that are above each other or beside each other. Each time you see such type of problems, in order to calculate A, you can study the system as a whole. So take the whole system and study it using Newton's second law in order to find A. This is one method of finding the acceleration. So I will start with this extra problem which says a block A of mass 12 kg rests on top of another block B of mass 20 kg, which in turn sits on a smooth horizontal table. So the block A is on the top of block B and the table is smooth. It means that there is no friction between B and the table. Okay? A 96 horizontal force is applied to the system of blocks in two different ways, once applied at block B and once applied at block A. So I have to deal with two cases. First case is if I'm going to apply F to A, and the second case if I'm going to apply F to B. That means first I'm going to push A so that the whole system moves, and in the second case I'm going to push B so that the whole system moves. In part A, it says calculate the least value of the coefficient of static friction between A and B if they are not to slide relative to one another in both cases. So بقلنا they are not going to slide as I'm pushing. يعني the force is exerted on A in case 1 or the force is exerted on B in case 2. All the system is moving together, but A and B are not sliding with respect to each other. A and B are at rest with respect to each other. They are at rest with respect to each other. كرمال هيك نوع الفريكشن بيناتهم هو static friction مش kinetic friction. لو كانت ال A عم تسحط على ال B أو ال B عم يسحط على ال A عم يتحركوا بالنسبة لبعض، كان نوع الفريكشن بيناتهم اسمه kinetic. بس لأنهم ثابتين بالنسبة لبعض والبي مهدي ال A اوكي عطول حملته وما عم تسحط عنا، so it's called a static friction. We have to find mu s in this case, and the condition is that they are not going to slide with respect to each other, so we have to consider that they are both moving together with the same acceleration. So I will start first solving case A, then I will move to case B. So A, let me write first that A and B do not slide with respect to each other implies they have the same acceleration. The same acceleration. Okay, now how to solve? We consider the whole system together. Let me consider the system. Consider the system. I will write here case A because I'm solving case A. So it's case A, case 1, part A. Okay, the system, consider the system A plus B. Okay, this is my system. I'm solving case 1. This is A up and B down, and B is lying on the ground. There is no friction between B and the ground. Okay, let's apply Newton's second law. Apply Newton's second law. It says sum forces external on the system, it's equal to the mass of the system. The mass of the system is MA plus MB because I'm applying it on the system, times acceleration, the acceleration of the system. All the system has the same acceleration. A and B have the same acceleration. So what are the forces acting on my system? The external forces acting on my system. First, I have normal of B due to the ground, so the normal, I will draw it this way, so this is the normal force on B, okay. There is no normal on A because الأرض مش حاملة ال A، الأرض حاملة ال B. This is the normal on B. الفورس ما بين A وال B كانت friction، أو الفورس ما بين ال A وال B كانت إنه ال B is carrying A normal of B on A or normal of A on B because A is also in contact مع B. These are internal forces ما بياخدهم بعين الاعتبار. The external forces are forces exerted on the system due to objects that are outside the system. برات السيستم. الفورسز اللي هني بيجوا من objects that are inside the system هني يعتبروا internal force. So my system is composed of A and B. Any force caused by A on B or by B on A is considered internal. هلا أنا الإكسترنال هن normal للB. This one is caused by the ground. Normal للB أو the table. Sorry, the table is carrying the block B. So the table is an external support. So it's considered the normal force exerted by the table is considered as an external force. What are the other? There is no friction from the table or the ground on B. There is no friction. We have the weight of A, the weight of B. We can say it's the weight of the system, which is the weight is vertically downward. It's MA plus MB G. This is the weight of the system. Okay, and we have the force that we are exerting. It is on A. Okay, the force F. You can see that F is along x-axis, N is along y-axis, and MA plus MBG is also along y-axis. So I will take x-axis this way. دايما بناخد x-axis مع الموشن وال y-axis بيكون perpendicular مع x-axis. So let's write our forces. I will get F plus NB plus MA plus MBG. This is equal to MA plus MBA. Now I have to projection along x-axis, projection along x-axis. هلا هون أنا ما راح يفيدني y-axis، ما راح أحتاجها. So I will only do on x-axis because I'm searching for A. All the forces along x-axis are equal to MA. So مين في عندي على A؟ في عندي F equals ما في إلا ال F along x-axis equals MA plus MBA. So كل شيء على ال x-axis بيساوي MA plus MBA. اللي على ال y-axis بيساوي 0 اللي هني NB minus MA plus MBG is equal to 0. I won't write it because I'm not searching for it. So implies I'm searching for A. A is equal to F over MA plus MB is equal to 96 over 32. Because we had 12 and 20, we will get 3 meters per second squared. بس نحنا ما كنا عم ندور على الاكسلريشن. We were searching for mu s, which is the coefficient of static friction between A and B. لحتى أنا لاقي الميو s, I have to divide fs by n. So أنا اللي مضطرة لاقي الفورس اللي هني between A and B. To find the forces اللي هني من internal forces. إذا أنا باخد السيستم A B, I have to change my system. So باخد يا البلوك A لحالة أو البلوك B لحالة. So بصير أنا عندي بهالحالة frictional force between A and B is considered as an external force. شو عم بعمل؟ عم غير السيستم تاعولي، ما باخده كله سوا، باخد بس بلوك وحدة. بهالبلوك الوحدة الفريكشن ما بين ال A وال B بتصير تعتبر external force منا internal. So I have to add it if I'm applying Newton's second law. I will just mark the answer here. So the acceleration of the system is 3. Okay. Let me now consider system A alone. Consider system A alone. راح اخذ البلوك A. Let me draw block A. This is block A. alone, it's standing on block B. So what are the forces acting on block A? This is block A. They are the weight of A, which is MAG, normal exerted by B on A, because مين حامل ال A؟ ال B, so it's the normal exerted by B on A, and we have the force F that we are pushing with, and احنا عم ندفش ال A. And what do we have also? We have the friction. So the friction is drawn this way. This is the friction, which is the static friction. It's backward. Okay. لو ما في friction بيناتهم كنت إذا أنا بدفش بال A لازم تمشي ال A وتبقى ال B مطرحة. أوكي. يعني ما تلزقوا ال A وال B ويمشوا سوا. لو ما كان في friction ما بين ال A وال B. So let's apply Newton's second law. sum لل F. sum لل F external, it's equal to MAA. الماس لل A بس. So I have 4 forces, F plus Fs plus NB over A plus MAG is equal to MAA. Okay, now I will project along x-axis and on y-axis. So projection along x-axis. مين في على x؟ مثل ما قلنا ال direction of motion هيك على اليمين. So I take x-axis to the right, y-axis upward. مين في على x؟ في عندي ال F plus F minus Fs لأنه بعكس ال x-axis. So it's minus Fs. كل شيء على x-axis هو it's equal to MA or MAA. Don't forget the index of the mass. These are. هلا الاكسلريشن هيدي اللي انا معي اياها هون، هيدي هي ذاتها طلعتها فوق، لانه الاكسلريشن للسيستم اي بي كله مع بعض هي ذاتها الاكسلريشن لل A، هي ذاتها الاكسلريشن لل B. So A I have it up. So if I have to find Fs I will get Fs equals F minus MA. Okay, I will substitute at the end. Let's now project on y-axis. I will get مين في عندي ال N exerted by B on A upward, so it's plus minus MAG, it's equal to 0. كل شيء على ال y-axis بيساوي 0. So N exerted by B on A, it's equal to MAG. I have the mass, I have everything. صار معي ال Fs ومعي النورمال. هلا صار معي now I can calculate mu s. Mu s it's equal to Fs over N. It's equal to Fs معي إياها F minus MAA over N, which is MAG. I can separate them if I like or substitute directly. F it's 96 minus the MA was 12, the A was 3 over 12 times 9.8. Then I get mu s, it's equal to 0.51. Remember that the coefficient of static friction and the coefficient of kinetic friction has no unit. Okay. كمان فيني أنا حلها بأخذ السيستم بي لحاله. فيني حلها but it will be harder. I will let you see that I can use B alone and find the same answer. So I will move downward a little bit. But I advise you each time you are going to find mu s, خدوا the upper one. Take the upper object. It's easier to find Fs and N from the object. So I will solve it. I will allow you to see it. So implies, let me remove the implies. It can be also solved using system B. Okay, so let's study system B. هيدا system B اللي هو كان واقف على ground. Okay, this is system B. What are the forces on B alone? On B في الويت لل B which is MBG. في عندي النورمال من الأرث أنا سميته NB. اوكي، في عندي الفريكشن مع الاي. اذا بعدكم ذاكرين الفريكشن اللي كانت عم تعملها الاي على البي was to the left. so اذا بعدكم ذاكرين according to Newton's third law لما الاول يعمل فورس على الثاني الثاني بيعمل فورس على الاول same magnitude opposite direction. so بهيدي الحاله الاف S exerted by A on B will be like this. It will be forward. This is Fs exerted by A on B. لأنه Fs above exerted by B on A was backward. Okay, it was backward. N اللي كانت لعنا N exerted by B on A كانت لفوق. So N exerted by A on B is downward. This is N exerted by A on B. رح ارجع عيد كيف عرفنا senses of Fs and N. Fs exerted by A on B and N exerted by A on B. They have the same magnitude, opposite sense to N exerted by B on A and F exerted by B on A. بالforces exerted on A شفنا أنه we have drawn Fs to the back, so I have here to draw Fs to the front because they have opposite senses. And هونيك normal exerted by B on A was upward, so I have here to draw normal exerted by A on B downward. Okay, they are action-reaction pairs according to Newton's third law. Now let's apply Newton's second law for block B. Sum للF external is equal to MBA. So we have four forces. They are N exerted by the ground on B plus N exerted by A on B plus static friction between exerted by A on B plus MBG. Now I have to project along x-axis and on y-axis. مين في عندي على x-axis؟ في بس عندي ال Fs. I will take space. Okay, so along x-axis I have Fs only. Fs exerted by A on B, it's equal to MBA. And along y-axis I have NB. I have minus NA over B minus MBG. It's equal to 0. Everything on y-axis is equal to 0. هلا to find mu I have to divide أي n. بختار ال n exerted by A on B ولا ال n exerted by the ground on B. Because I'm talking about mu which is between A and B, so mu s هي فعليا mu s. Let me find هون n exerted by A on B. It's equal to NB minus MBG. So mu s it's equal to Fs for A on B over N A on B. لازم يطلع معي نفس الميو اس فوق which is MBA over NB minus MBG. But you can see that we don't have NB, which is the normal force exerted by the ground on B. We don't have it. We can calculate it. How to calculate it? فعليا كان فينا نحن نجيبها باستعمال السيستم كله. لما أخذنا نحن السيستم the whole system. Let me move above a little bit. When I have considered the system, all the system together, you remember here, okay, when I considered the whole system together, consider the system, I projected only along x-axis. I can take the whole system together to find NB. If I'm projecting along y-axis, ما في عندي على y-axis إلا plus NB minus MA plus MBG, it's equal to 0. ما في على y-axis إلا two forces. So NB will be equal to MA plus MBG. So down, let me move down. Okay, so NB, I have said that in my case it's equal to MBA over MA plus MBG minus MBG. It will be equal to MBA over MAG. MB was 20, A كنا ملاقينا 3 over MA was 12, G is 9.8. We should get the same answer, which is 0.51. So please remember that we have used Fs. I will write it as a note. The friction exerted by A on B is equal to minus the friction exerted by B on A, same magnitude, opposite sense, and the force of contact between A and B, they have same magnitude, opposite sense. So A on B is equal to minus B on A. This is according to Newton's third law. This is for the first case لما كنا نحن عم ندفش بال A. Now let's do the same but for the second case, for case 2. For case 2, it's the same given, but instead of pushing block A, I'm going to push block B. Okay, so this is B, this is A. Okay, this is the table or the ground, and this is the force F. We are pushing B. So first أول شيء لحتى أجيب ال F exerted by B on A and N exerted by B on A كرمال نلاقي الميو اس اللي هي F over N. I have to find first acceleration of the system. باخد السيستم كله مع بعضه. اوكي، رح تلاحظوا انه ما في فرق بين الحل هلا والحل فوق. sum لل F equals MA plus MBA. عندي الفورسز على السيستم كله ال F. في عندي الماس MA plus MBG وعندي النورمال للB. أنا بيهمني بس اللي على الإكس axis to find A. رح يطلع معي F equals MA plus MBA. So I will directly write it. So consider system A plus B. Consider system which is A plus B. I will get F plus MA plus MB G plus NB, it's equal to MA plus MBA. Okay, so we only care along x-axis, so along x-axis we have F equals MA plus MBA, implies A equals F over same as above, okay, plus MB. It will be 3 meters per second squared. This is for the acceleration. Now I have to find the mu. رح حل بس أنا على طريقة واحدة، ما رح أخذ block B because the block B needs more work. I will choose block A because it's easier to find the friction and normal from block A. So let's consider system A alone. System A alone. So let's look at system A. I will draw a new figure for A here. This is block A. شو في على A forces? Forces that are on A are the normal, which is exerted N exerted by B on A. I have the weight of A, which is MAG. I have the friction exerted by B on A. اوكي، لانه نحن قلنا في فريكشن بيناتهم، لولا وجود هالفريكشن ما كانوا بيمشوا سوا، كان واحد بضل واقف مطرحه والثاني عم يمشي. اوكي، so how to draw the friction? The friction is drawn here forward. So this is Fs exerted by B on A. ليش الاف اس اتجاهها هيك؟ simply دايما تعريف الفريكشن it is the force that opposes the tendency of the object to move. تخيلوا معي إذا أنتوا بتدفشوا الأوبجكت بفورس F، بتدفشوا البلوك B بفورس F كبيرة، شو بصير بالبلوك A؟ بتوقع لورا. سو فعليا لأنه البلوك A عندها تندنسي توقع لورا، صح هي ماشي لقدام، سو الفريكشن اللي هي ما بينها وما بين البلوك B must be drawn forward. بينما بالإكزامبل اللي فوق I will go back up، لما أنا بدفش البلوك A، أوكي، لما بدفش أنا البلوك A it will be moving، قد ما أنا سرعت الأف it will be moving forward، كرمال هيك الفريكشن تاعت ال A لحالها هي backward. أوكي. وكيف بتعرفوا إنه أنتوا أصلا غلطانين بالdirection of friction؟ أوكي، لما تعملوا البروجيكشن إذا طلع معكم قيمة الفريكشن هي نيجاتيف it's wrong، لأنه دايما نحن we are using the magnitudes of forces. يعني أنا لما أقول FSA on B equals MBA هيدا بيعني إنه this F is the magnitude of the friction, so it must be positive at the end of calculation. Okay, we were here. I'll do some space. Okay, so what are the forces? They are N exerted by B on A plus Fs, which is force for sure exerted by B on A, plus MAG. These forces are equal to MAA, the mass of A times the acceleration of A. تعال نشوف مين عندي على الإكس. في عندي على الإكس في الFS، okay, plus Fs equals MAA. لاحظوا هون لو حدا حاط الFS لورا كان طلع معه minus Fs equals MAA, so it's wrong. ما MA positive minus Fs will be negative, so حاله رح يعرف انه هو اصلا راسم الFS wrong. So along y-axis I have NB over A minus MAG is equal to 0. صار معي الFS وبدي N، okay, it's equal to MAG, so I will move a little bit down. Mu S, it's equal to Fs over N, it's equal to MAA over MAG, it's equal MA مع MA is cancelled, so we will get 3 over 9.8 and the answer will be 0.3 approximately. كمان نفس الفكرة فيكم تاخدوا system B alone and find the answer. I won't do it. You can do it previously as the one I have done before. but ما في داعي للصراحة لأنه دايما البلوك upper block is easier to deal with. Let me now do the second part. In part B it says what happens if the horizontal table was not smooth with coefficient mu k equals 0.2. Calculate the magnitude of the force exerted by the blocks on each other in case 2. So I have to find the frictional force between the two blocks, one on the other, in case 2, if there was a friction between the table and block B. Let me be more precise and write the magnitude of the frictional force exerted by the two blocks on each other in case 2. So let's find the force between A and B. First, okay, this is part B. I have to find the acceleration of the system. باخد السيستم كله مع بعض. Okay, this is block B and this is block A. What are the forces? I will solve directly, okay? So consider system A plus B. أول شي بلاقي ال A. Consider system A plus B. What are the forces on my system؟ في عندي الفريكشن مع الأرض. هيدي الفريكشن هي عبارة عن kinetic friction لأنه الأرض عم تتحرك أو البي عم يتحرك بالنسبة للجراوند. Okay, so this is FK. This is kinetic friction, not static friction. كل forces between A and B يعتبروا internal ما باخدهم بعين الاعتبار. في عندي الويت لل A مع الويت لل B, so MA plus MB, MA plus MB, MA plus MB, G. I have normal لل B, normal لل B on the ground, so NB it's upward or perpendicular مع the ground. I have the force F اللي هي can't applied on B, so I'm only solving case 2 as the question said, so I'm solving case 2. Okay, I won't write it. Consider system A plus B. We have 4 forces which are N, B plus F plus friction with the ground plus MA plus MB G. This must be equal to the mass of the total system A. Let's now project along X and along Y. Usually X with direction of motion, Y is perpendicular. مين في عندي على X؟ في عندي ال F، في عندي minus FK. Okay, this is equal to MA plus MBA. مين في عندي على ال Y؟ في عندي NB minus MA plus MB، MA plus MB G. This is equal to 0. طيب هلا أنا بدي أجيب ال A. To find A ال FK ما معي إياها، بس أنا معي معطيني هو بالgiven mu K. So I can make benefit of mu K to find FK لأنه ال FK is equal to mu Kn. So let me write here FK it's equal to mu Kn for sure ال NB لأنه على الجراوند في عندي الفريكشن اللي هي ال FK وفي النورمال they are at the same site. Okay, NB and FK they are at the same site, so it's equal to mu K. I have it, it's given. بينما ال NB from here NB it's equal to MA plus the bracket plus MB G, so it's MA plus MB G. I can substitute numbers, but I usually leave them till the end because sometimes we ask problems with only letters, not using numbers, so you can know how to solve. So صار معي هلا ال FK. I can now substitute. I will substitute in the first equation. We have, I will take this one and then substitute. I will get F minus mu K MA plus MB G equals MA plus MBA. I will move downward كمان شوي. So A it's equal to F over MA plus MB minus mu K G. I have all numbers 96 over this was 12 plus 20, it was 32. Mu K was given 0.2 times 9.8. I will get the final answer. .04 meter per second square. وهيك لقيت الاكسلريشن الجديدة. هلا هو مش طالب مني الاقي الاكسلريشن، طالب مني الاقي الفريكشنال فورس اللي هي ما بين ال A وال B. شو بعمل الاقي الفريكشنال فورس؟ I take only one block which is the block A that is found up So let's consider system A alone. System A alone. إذا باخد السيستم A، okay, don't forget I'm pushing B. إذا عم بدفش ال B، so إذا بدها توقع على A بتوقع لورا، so الفريكشن لازم أنا أعرف إنه الفريكشن هي بهالحالة ال FS forward exerted by B on A. والنورمال is upward لأنه ال B is carrying A، حامل A، so it's upward and exerted by B on A. بعد في عندي الويت لل A which is downward MAG. ما في غيرهم، أنا ما في عندي force، ما عم أدفش ال A أبدا، so these are the forces on A. N B over A plus FS B over A plus MAG, it's equal to MAA vector. So أنا بس بدي لي ال FS, so I will only project along x-axis. هيدي ال MAG نزلت لتحت. So projection along x-axis شو بيطلع؟ FS B over A equals MAA is equal to 12 times 1.04 equals 12.48 Newton. And this is the answer. We'll solve now problem 54, page 146. In this problem we have 3 blocks that are aside each other and not on the top of each other, but anyway we treat it similar to the previous one. We take the whole system together in order to find the acceleration of the system. This is one way of finding the acceleration. 3 blocks are in contact with each other on a frictionless horizontal surface, as in figure P5.54. A horizontal force F is applied to M1. Take M1 equals 2 kg, M2 equals 3, and M3 equals 4 kg, and F equals 18 Newton. Draw a separate free body diagram for each block and find the acceleration of the blocks, the resultant force on each block, and the magnitudes and the contact forces between the blocks. Part D, I won't solve it. I will substitute it by this part D. I won't solve it. This part D. Okay. I won't solve it. I will replace it with part D. Calculate the acceleration of the blocks if they are pushed up on an inclined plane of angle 30 degrees. I will draw a separate free body diagram for each block alone when I'm solving. So I will start with part A. It says find the acceleration of the blocks. To find the acceleration, as I have told you, one of the ways is to consider the system all together. So I have 3 blocks, M1, M2, and M3. What do we have? Forces. We have external forces, the weight of the system, M1 plus M2 plus M3G. We have the normal. We can say it's N1, N2, and N3, or the normal for the system. Okay, it's N for the whole system. We have F, which is pushing M1. This is an external force. We have no friction with the ground, so I'm not going to draw it. The forces exerted by one block on the other are considered as internal forces if I'm going to study the whole system altogether. So I'm not going to take them into account when I apply Newton's second law. So let's consider the system M1 plus M2 plus M3, and let's apply Newton's second law. So we have sum للF external it's equal to M1 plus M2 plus M3A. We have N plus F plus M1 plus M2 plus M3. G it's equal to M1 plus M2 plus M3A. بما أنه أنا عم فتش على acceleration so I will only project along x-axis. ال x-axis مع الموشن راح أخده وال y-axis is perpendicular to x-axis. Projection along x-axis هيدا بيعطيني مين في على x في بس ال f plus equals m1 plus m2 plus m3a. I can now get a equals f over m1 plus m2 plus m3. It's equal to 18 over 9. It's equal to 2 meter per second squared, and this is the answer. So this is the acceleration. This is part A. In part B بقلنا the resultant force on each block. sum للF على for block 1, sum للF on block 2. So this is easy. This is part B. للبlock 1 sum للF external for block 1 it's equal to M1 A1 or A. Why A? Because all the blocks, the 3 blocks are moving with the same acceleration. So this acceleration has the same value as the acceleration of the whole system. So it's also 2. Along x-axis, if I'm projecting along x-axis, so I will get sum للF external along x-axis for particle 1 is equal to M1A equals 2 times 2, it's equal to 4 Newton. If I'm going to do the same for block 2, sum للF external on 2, it's equal to M2A. I'm projecting only along x-axis because the forces along y-axis have a sum of 0, so they are not to be considered. So sum للF external, I'm just calculating numbers, equals M2A. We had M2 3 times 2, it's equal to 6 Newton. Sum للF external for particle 3, it's equal to M3A, implies sum للF external for particle 3 along x-axis, it's equal to M3A, it's equal to 4 times 2, it's equal to 8 Newton. If I want to write them as vectors, I can do as well. So I can write them this way: sum للF external for particle 1, they are equal to 4i with the x-axis. Sum للF external for particle 2, they are equal as 6i. Sum للF external for particle 3, they are equal to 8i, if I'm going to write them as vectors. In part C, it says the magnitudes of the contact forces between the blocks, but the forces of contact between each block and the other. So هون لحتى الاقي الفورس اللي انا كنت اعتبرها internal بالنسبة للسيستم, I have to take each block alone in order to find this force. شو راح اعمل؟ راح اخد اول شي البلوك M1 لحالها. So let's take M1 alone. M1 الM1 في حدا M2, so I'm studying now M1 alone. This is M3. I'm studying M1. What are the forces on M1 alone? On M1 we have the weight of M1 vertically downward. We have the normal N1 created by the ground on M1. We have the force F that we are pushing with, and we have the force of contact between 1 and 2. So this is, let's call it F exerted by 2 on 1. This is the force 2 on 1. We have 4 forces. Now I can apply Newton's second law for M1. Consider the system M1. ليه أخذت الM1 لحالة؟ كرمال يبين معي الفورس exerted by 2 on 1. Sum للF external, it's equal to M1A. I have 4 forces which are F plus N1 plus F exerted by 2 on 1 plus M1G M1A. Let's project now along X and Y axes. في عنا على الX الF minus F2 on 1, it's equal to M1A, وعلى Y are equal to 0. N1 upward minus M1G is downward, which is equal to 0. I'm searching for F2 on 1, so التاني ما راح استعملها بس عملت projection anyway. F2 on 1 it's equal to F minus M1A. الF كان معنا إياها given 18 minus M1 was 2 times 2, it's 18 minus 4, it's 16 Newton. This is for F2 on 1, and remember that F2 on 1 is equal to F1 on 2, same magnitude, opposite directions. They are equal in magnitude. So remember that the force exerted by 2 on 1, it's equal to the force exerted by 1 on 2 according to Newton's third law. Now let's do the same to find the force exerted by 2 on 3 or the force exerted by 3 on 2. I will choose system M3 because it's easier. So consider system M3. You can also consider, for example, system M1, M2 together or M2, M3 together, but usually choosing one is the easiest. So I will choose M3. This is M2, and beside it we have M1. They are all lying on the same ground. What are the forces acting on M3? We have the weight, which is M3G, the normal, it's N3. We have the force exerted by 2 on 3, this is F2 on 3. You can see that F is not drawn، يعني الF اللي أنا عم بدفش فيها الM1 ما خاصة بالM3، أنا ما عم أدفش الM3، أنا عم أدفش الM1. أوكي، الM1 هو عم يدفش الM2 والM2 عم يدفش الM3، so الF ما خاصة بالM3. Let's apply Newton's second law. We have sum للF external, it's equal to M3A. We have N3 plus F2 on 3 plus M3G is equal to 0. It's equal to MA, M3A. So شو في عنا على X axis؟ في عنا ال F2 on 3 it's equal to M3A. وعلى Y I won't use it but I will project anyway, minus M3G is equal to 0. Now على X axis gives me F2 on 3 equals M3 was given 4 times 2 is equal to 8 Newton. So this is the answer. I can do the same لو أنا استعملت block 2. Let's see the forces on block 2. This is block 2 M2. شو في عليها forces؟ في عليها forces الويت تاعولها M2G في النورمال. اوكي، في الفورس exerted by 3 on 2. لاحظوا ال F3 on 2 بعكس ال F2 on 3 same magnitude opposite direction. وفي عندي كمان ال F exerted by 1 on 2. These are the forces on 2. كيف فيني نطبق أنا السيستم نيوتن second law on the system M2 مع ال F1 on 2 ومع ال acceleration. I can find F3 on 2, but for sure using M3 was easier. Now part D. part D is an extra exercise من عندي أنا بدل الدي اللي هني حاطينه. بقلنا calculate the acceleration of the blocks if they are pushed up on an inclined plane of angle. Let's make it 10. It's 10 degrees and not 30. I've printed it 30, but it's 10. So let us do the same. Find the acceleration if the motion is on an inclined plane of angle alpha is equal to 30. I will draw the inclined plane. This is M1, this is M2, and this is M3. And I'm pushing with a force F upward. So I will take x-axis with motion. This is x-axis, and for sure y-axis is perpendicular to x-axis. The forces acting on the system 1, 2, 3. Remember that I'm going to search for the acceleration, so I'm going to take the system as a whole. The forces acting on 1, 2, 3 together, it's the weight for the system, which is M1 plus M2 plus M3G. So M1 plus M2 plus M3 G. I have the normal of the system, which is perpendicular to the support. Okay, remember that this is the angle alpha, which is 10 degrees, and now I have to apply Newton's second law. Consider the system M1 plus M2 plus M3 and apply Newton's second law. So N plus F plus M1 plus M2 plus M3G is equal to the total mass of the system plus M2 plus M3A. Let's project along x-axis. Along x-axis. I don't care for y-axis because I'm only searching for A. So x-axis is enough. على x-axis في عندي الF وفي عندي شقفة من الويت لأنه you can see that the weight جاي oblique ما بين ال x-axis وال y-axis. If I want to project x along x-axis, so along x-axis we get mg sine alpha. Here at m total, m1 plus m2 plus m3 g sine alpha. I will write it as m total because of the space. And if I'm going to decompose or project the weight along y-axis, it will be mtg cosine alpha. I won't need it, but I'm just projecting it for you. So مثل ما شايفين على x-axis في عندي الF وفي عندي شقفة من الويت اللي هي m total g sine alpha. So it's minus m1 plus m2 plus m3 g sine alpha. This is equal to ma, m1 plus m2 plus m3a. Okay, I'm searching for a, so I'm going to divide by the total mass. So F over m1 plus m2 plus m3 minus g sine alpha. F was 18, we had mass 9, 2 plus 3 plus 4, minus G was 9.8 and sine 10, which is equal to 0.29 meter per second squared because you are searching for an acceleration. Of course, if you want, for example, to find the force of contact between each block and the one beside it, you take, for example, block 1 and you can find the force exerted by 2 on 1 by studying the system M1 alone. If you want to, for example, find the force F2 on 3 or F3 on 2, you can take the block 3 and apply Newton's second law for this block 3, studying the forces on this block, and at last you will find the force of contact between 2 and 3 after for sure finding the acceleration. I will now solve problem 2045, page 144. This problem is two blocks. They are connected by a rope. They are not in contact with each other. They are connected by means of a rope. So the two blocks connected by a rope of negligible mass are being dragged by a horizontal force. Suppose that F equals 68 Newton, M1 equals 12, M2 equals 18, and the coefficient of kinetic friction between each block and the surface is 0.1. Sometimes in some problems بيعطيني لكل بلوك ميو لحالة، ميو كاينتيك لحالة. ليه؟ لأنه ممكن يكون الجراوند هي ذاتها بس النيتشر اوف ذا ماتيريال، يعني إذا أنا عم شد صندوق كرتون غير ما أنا أكون عم شد for example صندوق نايلون. So the friction between each block and the ground can be different. It's okay. He can give me mu k1 and mu k2. I will solve in general وبعدين رح أعوض mu k1 equals 0.1 and mu k2 is also 0.1. بيقول لي draw a free body diagram for each block. So I will draw here. This is part A. I have for M1, this is M1 and this is M2. M1 في عندي friction. So we have for block N1 we have the weight which is M1G. We have the tension. Okay, the tension is always towards the string, and we have the friction. بما انه السيستم ماشي لقدام so the friction is backward. It's kinetic friction. I will call it FK1 because it is in motion. Okay, عم يحف بالارض so it's FK1. على البلوك الثانية M2 I have for sure the weight which is vertically downward, support N, the normal of the support which is perpendicular to the support. I have the tension towards the string and I have the friction opposite to the motion FK2. رح أرجع عيد it's kinetic friction because the blocks are in motion with respect to the ground. وفور sure عنا الفورس F اللي عم نشد فيها block M2. Import B بقلنا determine the tension T and the magnitude of the acceleration of the system. Here to find the acceleration فيني اخد السيستم كله مثل ما انا كنت عم بعمل بالبروبلمز اللي قبل. Okay, I can take the whole system, find the acceleration, but I have a problem that I don't know FK1 and FK2, I don't know them. بس معي الميو كي، معي الميو كي. So إذا أنا معي الN N1, so FK1 is equal to mu1, mu K1 N1, FK2 is equal to mu2 أو mu K2 N2. So إذا معي الN فيني أجيب الFK. كيف بجيب الN؟ Let's first choose the system M1 alone. This is part B. Consider system M1. بالM1 and let's apply Newton's second law. We have N1, we have tension, we have weight, and we have kinetic friction. Okay, which are all equal to M1A. مين في عندي على ال x-axis؟ في عندي minus FK1, this is minus, plus T equals M1A. ومين في عندي على ال y-axis؟ اللي على ال y-axis بيساوي 0 N1 minus M1G equals 0. اوكي، هلا اذا انا بدي احل هيدي، بدي اجيب الاكسلريشن او بدي اجيب التنشن. كلكم شايفين انه هون ما معي التنشن unknown والاكسلريشن unknown. الاف كي فيني اجيبها من الان implies فيني نقول انه الان 1 equals m1g، وانا في معي الاف كي هي عباره عن ميو كي 1 n1 اوكي plus t equals m1a. إذا أنا بوصل لعند هون tension is unknown and acceleration is unknown, so أنا ما معي هون. I need another equation. So let's consider the system. Consider system M2. بالنسبة للM2 عندي 5 forces اللي هن N2 plus F plus M2G plus FK2 plus T. هيدول كلهم بيساووا M2A. اوكي. so projection along x and y axes. ما تنسوا ال x axis مع الموشن اخذته انا، وال y axis perpendicular للموشن. هلا انا سميت التنشنز نفس الشيء بالروب لانه انا شرحت لما شرحت same rope same tension. هيدا لما يكون الروب of negligible mass. so let's project along x axis up back to the figure. اوكي along x axis مين في عندي؟ في عندي minus t minus fk2 plus f equals m2a. ومين في عندي على الواي axis؟ في عندي n2 minus m2g هيدا is equal to 0. ومن هيدا بيطلع معي أنا إنه ال n2 it's equal to m2g. هلأ صار فيني جيب ال fk minus t minus mu k2 n2 ما تنسوا plus f equals m2a. both blocks have the same acceleration because they are connected by means of a rope. كرمال هيك سميت ال A فوق وال A تحت، ما غيرت بالتسمية. ال M1 كان اسمها A acceleration، وال M2 كمان كان اسمها ال acceleration A. هلا you can see that we have two equations of two unknown. This is equation 1 في بقلبها ال N1 معي اياها، صرت جبتها هي M1G، ال mu K given 0.1، ال M1 معي اياها، وهيدي equation 2 مع كل شيء ما عدا t وال a. I have two equations two unknowns. I can find the acceleration and the tension ضربة واحدة. اوكي فيني كمان استعمل السيستم كله سوا مثل ما انا عملت المرة الماضية او بالاسئلة اللي قبل. consider system اللي هو M1 M2 والروب. اوكي so بهيدي الحالة sum لل F external is equal to الماسلess system اللي هو M1 plus M2. الروب ما إله ماس A. اتذكروا انه tension بهيدي الحالة يعتبروا internal force. so بيبقى معي ال external N1 N2 M1G M2G وال F وال frictions يعني FK1 و FK2. so I will project along x axis. أنا بس بهمني along x axis هلا along x axis. so I will get مين في عندي؟ في عندي ال F minus FK1 minus FK2 equals M1 plus M2 A. This is along x-axis. implies F minus mu K1 N1 minus mu K2 N2 equals M1 plus M2A. هلا already أنا كنت برهني من systems 1 and 2 إنه ال N1 هي قيمتها M1G. so F minus mu K1 M1G minus mu K2 M2G it's equal to M1 plus M2A. okay I have everything. ال F كانت معي 68 minus ال mu K1 هي 0.1. ال M1 was 12 times 9.8 minus 0.1. ال M2 was 18 G it's 9.8 equals the sum of masses it's 12 plus 18 A. so بنحسب ال A بيطلع معي ال A it's equal to 1.286 meter per second squared and this is the acceleration. هلا إذا بدي لاقي التنشن هي كانت تعتبر internal force بالنسبة للسيستم M1 M2 and the rope. so I have to choose one block to be studied in order to find T1. so أنا ما فيني لاقي التنشن T1 إلا إذا باخد واحدة من الإيكويشنز اللي أنا كنت جايبتها فوق من السيستم M1 and M2. مثل ما شايفين هون أنا راح آخد من السيستم من الإيكويشن 1 أنا معي T it's equal to M1A plus mu K1 N1 وال N1 معي إياها. I will move downward So from equation 1 implies T equals M1A plus mu K1 N1 اللي هي كانت M1A plus mu K1 M1G لأنه ال N1 كانت M1G. So I substitute with numbers, I will get T equals 27.2 Newton, and this is the tension. كمان كان في حدا يجي يعوض بالإكويشن 2 ويلاقي التنشن كمان صح. It's not wrong because the tension is the same in the rope in both sides of the rope. Now problem 24, page 142. A 5 kilogram object placed on a frictionless horizontal table is connected to a string that passes over a pulley and then is fastened to a hanging 9 kilogram object as in figure P5.24. Draw free body diagram of both objects. Find the acceleration of the two objects and the tension in the string. This pulley is massless. Okay, we are dealing with massless pulleys in this stage. We will deal with pulleys with mass at the end of the mechanics course, but till now the pulley is considered to be massless. So we're going to draw a free body diagram for this case. هلا هيدول الأسئلة اللي جايين كلهم فيهم pulley, and I will teach you how to deal in the case of objects connected through a pulley. So what are the forces acting on the first object? Let me call it M1. This is M1, this is object 1, with M1 equals 5 kilogram. The forces are the weight, which is M1G, the normal. قال إنه the table is frictionless. لو في friction بدي أحط friction للتيبل بس ما في friction. And the tension. Okay, دايما السترينج بشد لعنده. هلا بما انه هيدي frictionless pulley, التنشن قبل البولي وبعد البولي the same. It has the same magnitude. So هيدا البلوك M2 which has a mass of 9 kilogram is also subjected to a tension T. وهيدي التنشن T اللي على البلوك M2 نفس التنشن اللي هي على البلوك M1 because the pulley is massless. هلا لو كانت البولي عندها ماس كانت التنشن بالخيطين اللي هو الخيط الفوقاني والخيط التحتاني غير. It would be different. Okay. عنا الويت اللي هو M2G. Okay. These are the forces acting on block M2. So هون بهيك أسئلة ما بياخد السيستم كله مع بعضه. I treat each one alone. Okay. لأنه they are not moving on the same line. They are moving. Block M1 is moving horizontally and block 2 is moving vertically. So in this case, I treat each one alone. So let's consider system M1. Consider system M1, which is the first block. So in this case, let's apply Newton's second law. Sum F external equals M1A. I have three forces acting on it. It's N1 plus T plus M1G equals M1A. So let's project along X and Y axes. هلا بالنسبة لإلي الموشن هون يعني الموشن هي مع الإكس أكسس. اللي على الإكس أكسس هني بيساووا MA، اللي على الواي أكسس هني بيساووا 0. So I will project. مين في على الإكس أكسس في التنشن بس plus T مع الموشن. This is the positive sense of motion. وهون positive sense هيك لأنه it's going downward. هون it's going to the left to the right. So هون ال T هي اللي بتساوي M1A لأنه الموشن is to the right. بينما N1 minus M1G is equal to 0. اوكي نحن الاكسلريشن ما بنعرفها والتنشن ما بنعرفها. So I will use هيدي الايكويشن 2 ما راح استعملها but I project anyway. This is equation 1. I will use it later. So let's now consider the system. Consider system M2 and apply Newton's second law. We will find sum F external it's equal to M2A. لاحظوا كمان نفس ال A سميت فوق وتحت ما غيرت لأنه الاثنين موصولين بنفس البولي هي inextensible pulley, so both move with the same acceleration. We have only two forces, T plus M2G it's equal to M2A. لاحظوا هون positive sense هو downward يعني كل شيء على الفيرتيكال بيساوي MA مع الموشن بيساوي MA. كيف عندي الموشن downward so positive sense downward عندي plus ما في projection إلا على الواي anyway M2G plus minus T equals M2A. I project this way. هلأ صار معي two equations اللي هي equation 1 and equation 2 فيهم two unknowns اللي هن T وال A مع كل شيء مع the tension وال acceleration. I can take these two equations and find the acceleration. فيني أعوض التنشن من فوق من اللي تحت. So using equation 1 يطلع معي M2G minus M1A equals M2A implies M2G equals بجمع لي فيهم A على جهة واحدة plus M2A. So I will get A equals M2G over M1 plus M2. I have all the masses. M2 was 9 times 9.8. M1 was 5 plus 9 and I get the answer which is 6.3 meter per second squared. This is for the acceleration. هلا إذا بدي أجيب التنشن I can use any equation. كمان رح استعمل equation 1. So from 1 I will get T equals M1A. You can also use 2. It's equal to M1 was 5 times 6.3. I will get the tension which is 31.5 Newton and this is the answer for the tension. And this is the acceleration. So فعليا لما أنا حل pulley problems that contain a pulley شو بعمل؟ بحل كل side alone بيطلع عندي tension مع acceleration. I make a system of two unknowns and try to find the tension and try to find the acceleration this way.